Now we're going to talk about service-oriented architecture. Before we actually get to the content, I want to thank the Miami Innovation Center. Unfortunately, our host couldn't make it tonight. This is our first time in this space, as I said before. Unfortunately, the other space that we were using is closed. So we figured we'd try here. You know, a little bit of a challenge getting in the door, but hopefully that'll smooth itself out over the next several events that we have. Also want to thank our sponsor, Ranger Technical Resources, John Giovanni, the only guy in a tie back there. So they are our sponsors, so thank them for the food and for the prizes that we're going to be giving out. So there's John's contact information there if you want to get a hold of him. Ranger Technical Resources is one of the premier staffing agencies in South Florida. You guys, how far north do you guys go as far as reach?
In terms of just, I mean, we're working nationally.
Nationally, okay.
Yeah, we do work a lot of the clients, South Florida, West Palm and down, but I mean, the clients in the Bay Area, out in San Francisco, New York, Dallas, Colorado.
Awesome.
So
there you go, very cool. So they've been sponsoring Data Masters for a couple of months now. Data Masters itself has been around about 6 months and still growing, so we're over 60 members so far. Just gotta get them all to show up to events. Short bio about me. I've been working in the IT industry about 15 years. Most of that has been centered around databases. I started back with Oracle very, very early on, Oracle version 5. Been working with pretty much every database you can think of. MariaDB, MySQL, SQL Server, Postgres, Cassandra, Neo4j, Redis. I've even worked with some of the more obscure stuff. If you ever heard of like Mumps or Ingress, I've worked with that stuff too. I've worked across pretty much every industry you can think of, from consulting, retail, energy, gaming, now I'm in healthcare. So the opportunities there, basically the advantage of working across all the industries is you get to see so many different ways that each different location or each different industry uses data. One of the advantages of working in the database industry is everybody's got a database. You don't have to, you know, if you're a pharmacist, you work in pharmacy, that's about it. Working in technology, you can cross so many industries. So I found that to be a huge advantage. This is my website, dbtechpro.com, and there's my email there and my Twitter handle. So all of the slides from my presentation and the content from Christina's, we're going to make it available on dbtechpro.com, so you can go on there and download that. Also on there, on my website, I also have a technical forum, so if you want to ask questions, you go ahead and post. Relatively new forums, got a handful of users, not a lot of content, but if you have questions, go ahead and post. We'll get you answers. So now we're going to jump straight into service-oriented architecture. So can anybody give me what they think service-oriented architecture is? There's a lot of definitions out there of what it is. A lot of people have different ideas of what it is and how to use it. So can anybody want to give their ideas of what SOA is?
Sure, because I don't know. So
okay, for a guess.
I'll make something up.
Sure.
Whatever product or you're trying to design, whatever problem you're trying to solve, you split it into segregated services, okay, that are semi-autonomous from each other and have well-defined interfaces between each other. That's how you break it down.
That's a pretty darn good guess, because that's absolutely right.
So especially
if that was a guess off the cuff, that was pretty good.
Well, it does say service-oriented architecture, so I
there you go. So, Gil, did you have something?
No, basically it's like you have a library.
Okay.
Which libraries are what, like, I know a little bit of C, so it's just like a bunch of C libraries that are accessible with each other over.
If you think about it, you know, if you're used to coding, a C library,
right.
If you're thinking about maybe like a class, or like in PHP has classes,
right.
So a class can be called by another class, and then you just make the class available, and you can use it in your code. Take that concept and inflate it really big to like the platform level or the system level. So you're basically, like Lewis said, you're taking a group of functionality, group it together, and call it a service. And it's basically the same thing. You're just doing it on a macro level. So give it a breakdown here. It's a software architecture design pattern. It's not really.
Is it?
I think PowerPoint decided it could crash.
No, it's good.
Oh, you know what it is? I lost my video. There we go. So it's a software architecture design pattern. It's really geared towards platform level design. So it's not really tied to any specific vendor or any specific software, it can be used anywhere in any software with any combination of components. And the thing is, you design what you need it to do. You break it down into services specifically for making it loosely coupled and easily interoperable. So components are built as independent services grouped together by functionality. So for example, all of your login stuff goes into a login service. If you have a order service, or order functionality, you want to place orders, you place that into a service. All services are made available to applications or even other services. So you can have several applications that want to access whatever functionality you want to provide. Those applications just call a service by a very well-known definition or very well-known service call. That service call can be anything you want as long as all of your services use the same call. If you decide to use SOAP, you use SOAP. If you want to use REST, you use REST. If you decided you wanted to use, a direct IPC channel, inter-process communication, you can do that. As long as all of your services use the same approach and they're easily defined, easily understandable, and easily consumed, and the data coming back is in the same format, it should be very easy to integrate with any service that you create, as long as all the other services expect the same thing, expect to make the same type of call, get the same type of data. Hang on one second. I got this wonderful pop-up box. Keeps trying to get online. Okay, so let's talk about a platform, because we talked about service-oriented architecture is geared towards the platform level. So what would be a platform? Anyone? Or I guess a platform is pretty much anything. This is pretty much stuff you already know, believe it or not. So a platform is a technology stack. Something probably here N-tier, multi-tier. So you have an application, you have a web server, an application server, and then a data tier. So it's any kind of system environment. That is pretty much any platform that you want. It can be very small, just a group of functionality does one thing, or it can be very big, which has dozens of different types of operations working in concert. If you really want to get the most boring definition possible, you strip it down to a set of services made available, either internally or externally, to perform a collection of integrated functions, which could mean absolutely anything in technology. It could be a program, it could be a network, it could be a platform of services. The definition works, and it doesn't matter if you're writing a single executable program or if you're writing an entire operating system across the internet.
Yeah, it could be functional too. It doesn't have to, it could be like a sales platform.
Yes, it could be. And that's exactly the direction we're going. So, thank you. We'll see. So, traditional platform, I think you guys would recognize this. That's pretty much a traditional platform. This is what you'd expect to see. This has been around since probably the 80s or 90s. So you've got your application tier here, where all your requests come in from your external clients or users that will come in. This could be a website. This could be a desktop application. This could be a those old DOS screens that you see at the airport or something. It's the application. The application will access the data in the back end somewhere. And all of that sits on your infrastructure, which is all your servers and your network switches and all that stuff. This is the physical infrastructure that that's sitting on. Outside of that, you may have some batch processing going on. It pulls data through the application, some kind of scheduler to run it. This is pretty much where it starts, and over time you start to bolt stuff onto this thing because you need more functionality, and then you need flat files over here, and then you need some sort of archive over there. It just starts to span out, and it gets really costly to manage something like this, and it gets really difficult to add features and functionality. As you change things up here, you affect other things over here. If your database system crashes, the whole thing comes down. So it creates, while this has served most of the technology industry for many, many years, the expected uptime and the expected evolution of systems now, this doesn't really quite cut it anymore. So now we talk about a specific service. So what exactly is a specific service? We've already touched on some of it, and we're just going to talk about in detail what one service is. So a service is a self-contained unit of functionality. It does one thing and one thing only, but it does it well. And nothing else in the platform should be doing that thing. If you want to do that one functionality, you go to that service and it does it for you. So you group all of your business logic together by functionality, and that gives you essentially your list of services. It almost defines itself. It's not a whole lot of thought process here. So every single service should have a simple interface to access. Now, simple is relative. That interface can be as robust as you want, can provide as much functionality as you want, or it can provide as little functionality as you want. Simple means you know how to call it, and you know what to expect back from it. So simple means simple definition, easy to understand and easy to use. The functionality is independent of the underlying hardware. Behind that service interface, you can have any number of pieces of hardware. You can have hundreds of servers, you can have one server. It can be no servers, just a pass through to something else. You can have, terabytes of data, or you can have nothing more than a flat file that it reads from. It really doesn't matter what's behind it, as long as you call that interface one way and you get information back the other way. Some example of services, let's say you had a t-shirt website. That's what you did. You sold t-shirts. Now, I'm not talking about selling, a couple hundred t-shirts a day. I'm talking about selling thousands of t-shirts a minute. So I'm talking like Amazon size stuff. So you could break it out where you have a one service just for your inventory management. So as you want to keep track of your inventory, that information is coming in at such a high rate, you need to separate that out away from what customers are doing. So you may have a separate service manage your inventory, keeping your inventory quantities up to date, your inventory items up to date. You have customer management where people are signing up at hundreds per second. You separate that out to a service. So where people want to register on the website, there's a separate registration service that handles that. Order management service, as people are placing orders, this is really critical because if you drop orders, you lose money. So you separate that out into a separate service. All it does is handle the orders itself. The orders come in, people pay with their credit card, they hit submit, they're done. You can have a separate service that handles the credit card transactions. Shovel that off to somebody else, third-party service, let them handle the credit card so you don't have to store them and you don't have to worry about being liable for that. And that's going to really annoy me. They cut the Wi-Fi off.
So is the idea that if each one, like your inventory management, each one is backed by a separate database or NoSQL store or whatever, that those databases are completely independent of each other? That the only way you talk is through that interface?
Yes, the only way you get in and out of that service is through its interface. Okay. That should be the only way you get in and out. If there's functionality that you need, it needs to be built into that interface.
You want to hide the implementation.
Exactly, you want to hide the implementation. The beauty is that if you ever need to make changes to a service, you're only affecting that service. You can add stuff. If you need to add more servers, if you need to take the whole thing out, you want to take Oracle out and replace it with MySQL. You can do that as long as the end call that you make doesn't change. Everything else can continue working. And each one of these services can scale at their own rate independent of each other. So if you have, like for example, inventory management, you might need 100 servers to manage that, and then you might need 2 servers to manage customer management. So each one can scale at their own rate, and they're independent of each other. So let's take a look at a sample pattern of an SOA platform. This is non-specific to anything. This is just sort of a pattern that you can basically replicate and do a, find and replace on the words and make it work for whatever platform you want to build. So this is the same concept. Each one of these is a service. You've got functionality and or data. The front of each one you have an API, application program interface. That's how you're going to get in and out of it. It could be a simple REST call. It could be a PHP website. It could be HTML. It could be whatever interface you decide it's going to be, as long as every single one uses the same interface. All of this sits on your infrastructure. Nowadays, you're talking about cloud infrastructure. Forget about hardware. Who's going to buy hardware? Look to the cloud. The cloud is infrastructure becomes software. You need a server. You click a button. It spins up a server. You put your data on it. A lot of these are elastically scalable, so as you need more power, they start to scale up. As you need less power, they scale down. Theoretically, let's say you get busy during the day, during the workday, that'll scale up as you need, and then at night when there's less people on, it scales back down, and you're only paying for what you use. Down here along the side, we've got security, and the reason why it's going down the side is because that security should permeate the entire platform. So security is a concept that's not limited to a single service. Every service needs to have security baked into it. So in case somebody gets through this abstraction layer, that's about as far as they get. So user authentication, user authorization. Authentication says, am I allowed to log in? Authorization says, once I'm logged in, what am I allowed to do? So for both of those need to be built in across your platform. So in case anybody ever gets through your abstraction layer, even if they get back to the service call, make a direct service call, unless they're authenticated, they're not getting in. And if they're not authenticated, there's probably not have an authorization token or something like that, they're not getting past that API. So that security should be baked in. Making all of this automated as possible, you have orchestration. So these services can talk to each other, and that's done through an orchestration layer. We're going to talk about that in a couple minutes. So, now what does this exactly give us if we build a platform like this in a service-oriented architecture? Anybody have any ideas? What benefits can we gain from doing it this way as opposed to that traditional application stack? Sorry?
Reuse.
Reuse, so you can reuse these components. Good, very good points.
Runtime reuse and
Mhm.
development time reuse, right?
Yeah, so you can basically build a template of a service, and you can spin up 10 services, each one doing a slightly different thing, but all the common functionality, all your primary framework for like your API calls can already be there. You just fill them in with the different functionality that you need. Also at runtime, like you said, runtime reuse. So if you have customer management, you can use that to support your website for user registration, but you can also make those same calls if you ever wanted to dump out a list of all your customers and send them junk mail, which never happens, right? So you get simple integration, so you can build an API to integrate with somebody else very, very quickly. If you have a partner or a customer that they need to talk to your system, you build a service just like any of the other services. You tell them what the API is. Here's all your calls. Have at it. And they can connect to it, and they can work directly with your backend system through that API. And you can bake security in so you know that they're only coming from your client, so it's not being abused by somebody you don't know. Only your client, your partner comes in, they get authenticated, they get authorized, and they can integrate with your backend system. Interoperability, services talk to each other, the applications talk to services. It becomes very easy to make all of this interoperate as long as you have a very simple interface per service. Fault isolation is very important. No, you really don't want anything to break, but something's going to break, it's inevitable. So if something's going to break, you want it to affect the smallest piece of functionality in the platform possible. Bear with me for 1 second.
Turn the Wi-Fi off.
That's about what I'm gonna do, because this is getting annoying. So if something's going to break, you want it to affect the smallest piece of the platform as possible. That fault isolation, if you have something break inside a service, only that service is broken, or maybe only one part of that service is broken. So for example, in that t-shirt website, so if you have your inventory management system go down, maybe you still have caching up front and you can still run the website and people can still place orders, but they just can't update the quantities of their inventory. That's probably okay, they can probably still function and take orders. And scalability, as I said, each service can scale independently from other services. So, service-oriented architecture, there are some high-level goals here for service-oriented architecture. The reason why we're doing this. And we're going to talk a little bit on the business side a little bit. So our goals here are business transparency. The business should not know or care what's going on the technology platform. They just want it to work. And if you've worked in any amount of time in the technology industry, I guarantee you start talking technology to some of the people on the business side and their eyes glass over. They're like, I don't care. Just make it work. So they don't really care about how the platform works. You make this thing as simple as possible and the thing will just run. Asset reuse and consolidation. As Mike said, you can reuse these assets over and over again. These services become capable of doing other things. If you have a 3 or 4 services that provide certain pieces of data, you may write a 4th service that accesses that data and send it to somebody else. You can reuse those components as much as you want. Loose coupling, again, they're independent, they're very loosely coupled, they're not tightly coupled, so if one goes down, the other one still functions. Modularity and componentization, we're still talking about that loose coupling and everything is modular, everything is self-contained. So some of the principles that we're talking about, these are the things that we want to focus on over the things we don't want to focus on. For example, business value over technical strategy. Doesn't mean we don't care about technical strategy, but we prefer to focus on the business value. We want to focus on what does this give us rather than how we're going to go build it. We already know how it's built. Let's focus on how we can take this thing and make money off of it, drive more value from the system. We care more about our strategic goals over project-specific goals. We can spin up a new project that is self-contained by itself and put all of our resources behind it, but where we really care is long-term strategy. And if we have a platform that interoperates, we can stand up these little projects inside of that and focus on the overall strategy rather than throwing all our resources behind one project. Intrinsic interoperability over custom integration. So for example, we have these customers or clients or partners that want to integrate with our system. We would rather just plug them in and make them work rather than every single partner or customer that comes to us. We don't want to have to custom integrate every single one of them every time they show up. You get 10 customers, you have 10 custom integrations. Who wants to do that? You can build it once and you have 10 customers come in, they just plug in. At that point, there's no difference between 10 customers and 100 customers. They just bring as many as you want, they should all plug in and work. Flexibility over optimization. That doesn't mean we don't care about optimization. We do, but we don't want to spend a ton of time optimizing. We don't want to build a new system and then optimize and optimize and optimize and optimize. We'd rather build it once, get it optimal, and now it's flexible, so as we want to add new features, we just plug in new features. Evolutionary refinement over pursuit of initial perfection. As we all know, nobody's ever happy with release 1. It doesn't matter how hard you try, release 1's going to have problems. Release 2 is better than release 1, and release 3 is better than release 2. We all know this. Every service that you put out there, there's always going to be ways to make it better. It's an accepted understanding that as you build something like this, it's never perfect the first time. Over time, you evolve it, and it starts to come up to speed to where the business needs it.
I think the common word there is agile, right?
It is, absolutely. Glad you came to that conclusion. So, let's talk about SOA concepts, actually building this thing, right? How do you build an SOA platform? Everything is a service, right? Everything. You take all of your functionality, group them together by service, everything is a service. So you treat everything as a service, you interact with it like a service. Each service has a simple interface. We already talked about that. It doesn't matter how much logic you have in it, as long as it's simple to access and simple to get data back, every service should have a simple interface. If you don't have an interface on it, it's not a service, then you're probably writing something custom to get to it. Every service does one thing and does one thing well. This is another interesting piece. There are two types of communication in an SOA platform. There's direct communication, which means you have some application talking directly to a service. I'm going to my customer service, get my customer information. Say get customer, pass in a customer ID, and it comes back with their whole profile. So that's direct communication. You can have indirect communication where something happens in the platform. Some service does something and it needs to just tell the world about it. And it's indirect. It's not directed to anybody, it just broadcasted. This happened, some event occurred. So for example, a customer is created. So the person that made the call says create customer, they get a customer ID back, they go about their way. But the customer service publishes that to the rest of the platform saying a customer just got created. Any other service in the platform that cares about that will grab that and do something with it if they need to. So that indirect communication is like a broadcast that says something happened and other services can consume that and use it. And you can have internal services and external services. Internal services means it's internal to your organization or inside your system. These are internal services that you know, you access, only your stuff access it. External services are stuff that you expose to the world. These external services could be nothing more than things that connect to your internal services, kind of like a firewall. So you can expose external services to your clients and your partners. Those external services really do nothing more than give a wrapper to your internal services. And the only thing they can call is the external services. We can provide filters in there. We can apply security layers in there. They come in, they say, I am customer 27. They can only see customer 27's data. So in the back end, the external service will call the internal service and pre-filter that data for you. So you can bake that in. They will only see what you allow them to see. So let's say your internal customer service had 50 methods to interact with customers. What you've exposed on the external services is 3 methods. It's all they see, it's all they know is there. You could take multiple internal services and group them together into a single external service. So in case, for example, let's say you wanted to create a external customer service and that passes in their name and 5 addresses. In the back end, you can have 2 services, one for customers, one for addresses. And that external service handles it for them. You're just exposing it as one piece of functionality to your external users. So here's an example SOA platform. So this is very simple. Let's consider this as our t-shirt website, right? So we have some person on the internet who gets on our web application, which is our website, and they log into the system. So they log into their authentication service and they get back a token. They're logged in. From there, we read in their customer data. So it gets all their account information, whatever they want to see. And they do a search on the site and it comes back with product data out of the product service. And it lists all the products that they want that they could potentially buy, and they sort through it and search through it and whatnot. They find a t-shirt they like, they place an order, that goes to the order service. Now internally here, we can have things happen. For example, let's say somebody places an order and that needs to be shipped out by UPS or FedEx. Well, UPS or FedEx needs to receive that information so we can have something go into an event service. Like we said, this is that indirect communication. So this order happened and the order service just broadcasts that. Whoever needs to know about that order, there, it happened. And that goes into this event service, which queues it up. And this other data publishing service grabs it out of the queue and sends it out to FedEx or UPS and say, here, this order happened, go ship it. Or this may be an external shipping partner, like drop shipping. So this website they don't even own the t-shirt, they don't even have the t-shirts on site. They just send the signal out to their drop shipper and the shipper handles it. So that's pretty much a very, very, very simple SOA environment. Now theoretically, you could do all of this on a single server, with a single website, with a single application. This is not really what this pattern is designed for. You could do that if you sold 100 t-shirts a day. We're talking about systems at scale. So if you wanted to sell 1,000 t-shirts an hour, you wanted to sell 1,000 t-shirts a minute, and you needed to break this thing, you needed to scale, you needed isolated, you needed more expanded integration with partners, this is the direction you would go. We're talking economies of scale when you get to service-oriented architecture. Let's ask this question. Let's say from here, you have this system. And now you decide you want to add some incentives to your website. You want to say that when customers come in, if they every time they buy 10 t-shirts, we're going to give them a gold star on their account. So when people see their profile, they can see, oh, they're like a frequent buyer. Or maybe you want to give them a $5 discount card. So how would we do that? How would we integrate that into this platform easily without interrupting the existing operations?
Add a gold star service.
Add a service. We can just add a service. We can add basically a reward service. So add a reward service. So basically we can create a reward service every time a customer places an order. That gets broadcasted out. It gets, obviously the normal order operation happens. So they place an order gets shipped. But that event gets published to the event service captures that, and the reward service is subscribed to that, and every time an order comes in, it grabs it. And then it tallies up all the previous orders for that customer, and every time that person deserves a reward, it gives them a reward, and it's all stored here. So every time somebody places an order and they hit that threshold where they get an award, the reward service handles all of that logic, separate from everything else. If the reward service breaks, it's unfortunate, they won't get their reward, but they're still going to get their t-shirt. So that won't affect anything else.
But the rewards will get to them for a long time until you go back and redo and make sure that all the order events get resent to the reward database or the reward service. Right?
Yes, because you can persist those events here in the event service if you use persisting queues.
Right.
So if the queuing system goes down, the order still goes out. Well, the order still gets placed. If it has to go to a drop shipper and the queue's down, they may not get it. But the beauty is because this is service-based and it's isolated, you can build each service to be as resilient as you want. You can put as much high availability into that as possible. You can put clusters in there and put redundancies, and you can put load balancers and failovers. So you can have multiple persistent queues and replicated queues, and so one queue goes down, it picks it up from the other one, and you put logic in there. The beauty is in order to get in and out of that particular service, you just make one service call. And everything else is handled behind it.
And their entire libraries for doing everything you're saying? Like entire standard design libraries, if you will?
These are just basic, any kind of type, whatever call you decide to make.
Obviously, it's not going to reward you, open source reward service API, but there is a standard library that people can use for these persistent queues and things like that, or you should reimplement them on your own.
Yeah. Behind the API, you can build whatever it is that you want. If you want to build a custom, you can build a custom. If you want to use stuff that's out there, if you want to use like RabbitMQ, ActiveMQ, there's queuing systems that'll do that. Any one of these services behind, we're going to go in detail a little bit about some of these services, but behind each one of these APIs, the service itself can contain whatever it is that you need to make that service work. Consider that service its own application. It can have databases, it can have other applications, it can have gateways to other services. Whatever it is that you want, you're just grouping it all together as a single interface to access. Matter of fact, that's actually the next slide. Go next. There we go. Service implementation. So we're going to talk about what's inside of a service. And as I said, it can be anything that you want, anything that you need to make it work. You can have nothing more than a simple database. I mean, as simple as that. You can have an API with a database. You could have a cluster of databases that maybe this is all replicating to each other. Maybe this is geographically replicated. You've got one database here, one database in Virginia, one database in New York, and you have a single API to get to it. And inside that API, it makes a decision where to go and get the data. You can have multiple databases and some sort of background process. It doesn't really matter what that background process is. It doesn't matter what it is, as long as you have a simple API to get to it. You can build whatever that functionality needs to make it work. As I said, it can even just be a pass-through. This API is nothing more than just a connector to some other external process. Maybe, like you said before, you place a credit card order, You're going through the website is calling an internal service which handles that credit card order. Maybe in the back end, you decide you're going to use Authorize.net. 6 months down the road, you fire them and you're going to do only PayPal. The service here doesn't have to change. The connector changes and handles it for you. So this may be just a pass-through to some other external service that your system is making use of, and you're just exposing it as a simple API that doesn't have to change for the rest of the system. So, how do you get there? How do you go from this monolithic technology stack into a service-oriented architecture? How do you get there? What's your roadmap? What do you think you would do to take steps to go, okay, we're here, this ain't working, how do we get over there? Which I think would work.
A bunch of tests.
What's that?
A bunch of tests,
Bunch of tests, like what?
so that you would be testing everything that the monolithic service does, and then, so as you integrate new services, you can make sure that they are doing what the monolith.
Okay, but that's definitely going to be part of it, I think, when you get there. I think before you get there, you sort of have to start prototyping what your services are going to be. So basically, your steps are going to be, you want to identify the common logic, right? Go across your entire application, find all your login stuff. Where's all the logins happening? Where's all the authentication happening? That has to go into one service. Where's all of my order processing at? It could be 18 different places. Put all that in one spot. You start to look through and sort of take inventory of what your system does, categorize it, and that naturally becomes your services. And then you continue to refine it until you have a set of services that makes sense. Excuse me. The beauty is that you can use your imagination. If you need some functionality that's not already there, you just create it. You just draw a box, hey, there's a new service, and we'll put whatever we need behind it. And then over time you evolve it, and then you get it to do what you want it to do. So you group common logic together to create the services, and then you just go through and implement them service by service. As you implement each service, you have to retrofit the existing components. Remember, we're not just going to build a whole new thing, and then one night, in the middle of the night, we turn this one off and turn this one on. In reality, that doesn't happen that way. You have to keep the lights on. You have to keep making money, because most companies aren't going to run systems unless they're making money off of it. So you can't just turn one off and turn one back on. Companies that have tried that have usually failed. So if you turn this off, you turn it back on, you have orders coming in the new system, and that doesn't work, you have to go back. Well, all those orders that are in the new system are now orphaned. You have to make a transition from one system to the other. So you stand on one service and you retrofit everything, all that functionality into the new service. And you just do that repeatedly. Stand up the next service, retrofit everything. Over time, you start to transform it. It is not a fast process. It is something relatively slow. And orchestration of the various teams to make that happen, it can be quite painful unless you get everybody on the same page and everyone knows what the roadmap is. And then once you get your services standing up, you iterate them over time to improve them. Remember, the first attempt is never right, it's never perfect, you're never happy with it, and you just continue to evolve it over time to improve them. Do we have any questions?